Hello students, in this video I'm going to discuss a slightly tricky question. See, in this question I have seen that not only students but some teachers also make mistake. See, the question here is this. There is a uniformly charged hemisphere and you have to calculate electric field at the top of at the topmost point. Okay, at this point you have to calculate electric field. So if you calculate electric field directly by considering a ring or by considering a small element, okay, you end up getting a wrong answer. Okay, so the question arises, why do we get wrong answer? The wrong answer, actually comes because of the mistake in the integration process. Okay, what actually happens is that integrand, the function which you are integrating, actually is not defined at all points within the limit. Okay, so that's why we get wrong answer. So here I'm going to first discuss how we get wrong answer, and then I will tell you how to get correct answer actually. Okay, so suppose we want to calculate electrical here. So the most elementary method I'm going to use here. Okay, we can calculate it using ring also, but I'm not taking ring. I'm considering a small element here. So suppose I take a small element here, something like this. Okay. So this element, I'll say that it has charge dq. Okay. So and its area is suppose ds. So that's what we will say. Okay. So this is the topmost point. Okay. It is slightly here. This is the this is the topmost point. Okay. This is the topmost point. It will be exactly above the center. So here we have to calculate the electric field. So I have taken an element here. Suppose this element is at angle theta. Let's say this direction is z direction. Okay. So from here, if you can, because of this element, if you calculate field here, then direction of field will be something like this. So let's say this field, because of this elementary charge, is d, and let's say this angle is alpha. So this angle will also be alpha, and since this side and this side are equal, okay, this is r, and see this point is just above the surface, so this is also r. So therefore, this angle will also be alpha, and this angle we have taken to be theta. Okay, so sum of the three angle is 180 degrees, so we'll get 2 alpha plus theta is equal to pi. So therefore alpha will be equal to pi minus theta by 2. Okay, we know that because of symmetry, field at this point will be in z direction, so therefore we can say that we will have to just take z component of this field. Okay, so net electric field, if you calculate, you can write it like this: de cos alpha. Okay, now here you see dE will be equal to K, and because dQ and divided by distance square. So let's say this distance is d. Okay, so we'll have to write something like this: distance square, and this cos alpha, in place of alpha we'll write pi by 2 minus theta by 2 from here. Okay, now d we can calculate. To calculate d, we can just draw a perpendicular from here like this. Okay, this perpendicular. So using this angle will become theta by 2. So we can calculate d here. It will come out to be 2r sine theta by 2. Okay, you can calculate d using this small triangle. Okay, so that is, so let's put that here. So this is k, and dq you can write sigma ds. Okay, and divided by this much. So this becomes 4r square, and here you get sine square theta by 2, and this becomes sine theta by 2. Okay, and this integration. So we get k sigma outside, and divide by 4r square also outside we get. Okay, and one sine theta will cancel out. So you will get here ds, or divided by sine theta by 2. Okay, so this is the integration that we have to do. So we are integrating this function sine theta by 2 on this uh, 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 surface. Okay, so we are integrating this function on this surface. So we have to say that we are basically integrating 1 by sine theta by 2 on the surface. So that's why we are doing here surface integration. All right. Now you see here limit will be, see, we have taken an angle from this line. So limit will be 0 to pi by 2. Okay, so here limit is 0 to pi by 2. Now you see at theta equal to 0, this integrand. So integrand here is, you can say integrand यहाँ पे जो है, integrand, that is equal to 1 by sine theta by 2, which is not defined at lower limit. Okay, we are integrating on the surface. All right, so it is not defined at theta equal to 0. So that actually leads to the mistake. Okay, so if we can avoid this, okay, then we'll get the correct answer. So let us do it by some other method. So now if you put the value of ds here and you do the calculation, then it appears as if you are not making any mistake, okay, and you end up getting a wrong answer. Okay, so we can put ds here. Okay, ds अगर आप ऐसे put कर दोगे ना यहाँ पे देखो, ds will be equal to r square sine theta and d theta and d phi in spherical polar coordinate. Okay, we can write like this. So d phi integration will be 0 to 2 pi. So you can write it like this: r square sine theta and d theta and 2 pi. So now if you put this here, it appears as if sine theta by 2 will, this sine theta can be written as 2 sine theta by 2 cos theta by 2. So sine theta will cancel out. Okay. And so if you integrate, you will get some answer. Okay. So you put this here and integrate, you will get here E is equal to something sigma upon 2 root 2 and epsilon naught. So this is actually wrong. Okay. This is the wrong answer. Problem here is this. See, once you put the area, it appears as if there is no problem. Okay, but problem is with this integrand. Here we are not integrating on theta, but see, integration is not only on a planar angle. Integration is on surface. So we have to say that here integrand is 1 by sine theta by 2. This is the integrand. Okay, this is the कह सकते हो variable on which we are integrating. Okay, so integration is on surface. Okay, so after you put the area element, it appears as if there is no problem. Okay, but problem is because of this one. Okay, so now let us do it correctly. Okay, so here we'll have to take proper limit. Okay, then we'll get the answer. So what I'll do is that instead of calculating electric field exactly at this point, we'll calculate electric field at some point here. Okay, here a little above this point. Okay, so in that case, there won't be any problem. So let's do that. Okay, so here there is a hemisphere. It is something like this. Sorry. So there is hemispherical surface. थोड़ा अच्छा नहीं बन रहा है, ठीक है? So here, suppose this is z direction, and here we consider a point. Okay, this I'll take as origin. So this distance is suppose z distance, z, where we want to calculate electric field. So again, we'll proceed in similar way. We'll take a small element dq here. Okay, and so this will be at distance because it is on surface. Its area is ds, and we'll take this at angle theta. This angle we are taking to be theta. So here we are now calculating dv. Okay, let us calculate potential first, and using potential we'll calculate field. So now if this distance z, this distance is r, so if you calculate this distance using a cosine formula, you will get here this is r square plus z square minus 2r into z and cos theta. So that's what this distance is. Okay, तो ये distance इतना आ जाएगा. So now you calculate dv. So dv will be equal to, you know that k dq and divided by distance. So the distance is r square plus z square minus 2rz and cos theta. So that's the electric potential because of this element. Okay, so let's integrate it and calculate total potential. So k dq and divided by, ठीक है ना, here this is r square. So dq, in place of dq we can write sigma ds. So this is sigma ds, and this is r square plus z square minus 2r into z and cos theta. ठीक है. So here again theta का लिमिट 0 से pi by 2 वगैरह हम ले सकते हैं, ठीक है ना. Theta will be 0 से pi by 2. Now if you see, since z is greater than r, you can see here z we have taken to be greater than r. So this integrand won't, this denominator will not vanish at any value of theta. Okay, at any value of theta this is not going to vanish. Okay, so there is no problem. Okay, so let us integrate. So here ds, as I said earlier, this will be r square sine theta and d theta, and d phi we can write here, which will be equal to 2 pi. Okay, when you do phi integration. All right, so that's the ds. So let's put this here. So v will be equal to integration k sigma, and ds is r square sine theta. So this is sine theta d theta. So we can write it as this. This will become equal to minus of d cos theta. So this sine theta d theta can be written as minus of d cos theta, and this is 2 pi. And here we have root under r square plus z square minus 2rz and cos theta. So when you integrate, see now integration is with respect to cos theta. There is cos theta term here, or we can say we can put cos theta is equal to t. So it will become dt and here t, and then we can integrate it easily. Okay, so therefore what you are going to get here is k sigma and r square See, this is sigma, and this is r square, and here we have 2 pi. And when you integrate this, okay, you will get here, there is a, you will have to, there is a factor of 2 also. So there is factor of 2 rz. So when you integrate with respect to cos theta, you will have to divide by, coefficient of cos theta is minus 2 rz. So when you divide by minus 2 rz, you get here minus 2 rz, and there was minus sign here. There is minus sign. So this minus will cancel out. Okay. And we have written everything, right? K sigma r square 2 pi. All right. So, and this, see, power is here. If you take it to the numerator, power is minus 1 by 2. So on integration, you will get minus 1 by 2 plus 1. So it will become plus 1 by 2. So you will get here r square plus z square minus 2 rz. Okay, and cos theta. And here power will become 1 by 2, and you will have to divide by 1 by 2. Okay. And now here you see limit is 0 to pi by 2. Okay. That's what you get. So now you see potential is coming out to be, potential we are calculating at distance z. Okay. So if you put theta equal to pi by 2, this term becomes 0. See, this 1 by 2 will go in the numerator. So 2 and 2 will cancel out. Minus minus also cancel out. So, and 1 r will also cancel out. So we get here k sigma, okay, and 2 pi, and divided by z, and 1 r will be there. Okay. 1 r is there. So this is what we have now. Okay. And when you put the limit, you are going to get here r square plus z square, okay, whole power 1 by 2, uh, because theta makes it 0. And when you put theta equal to 0 here, it becomes r square plus z square minus 2rz. So that is basically z minus r whole square. Since z is greater, so that's why we will write it like this, minus z minus r. It is explicitly shown that z is greater, so that's why we'll write it as z minus r, not as r minus z. All right. So that's what we are getting. So this is the potential. Okay, we can multiply by this 1 by z, and we can put k equal to 1 by 4 pi epsilon naught. So that 2 pi will cancel out. So you'll get sigma r upon 2 epsilon naught, and here you will get r square plus z square whole power 1 by 2, and here z minus z से इसे multiply करोगे तो 1 minus r by z हो जाएगा. ठीक है ना? This we get. So that's the V as a function of Z. So therefore, if you want to calculate electric field at that point, you can just write E is equal to minus dV by dZ. All right. So let's do that. Okay, so let's differentiate it. So there is minus sign, minus sigma r upon 2 epsilon naught. And when you differentiate this one, first you differentiate this numerator, you will get 1 by 2. And when you differentiate z, you will get 2z. So 2z will cancel this z. And so ultimately you are going to get this r square plus z square whole power minus half. Okay. And when you differentiate this one, it will become 0 and minus minus plus. And when you differentiate 1 by z, you will get here minus r by z square. So this is what we are getting. And now since we have to calculate electric field at this point, so this point will be at a distance r from here. So we'll put z is equal to r here. Okay. So therefore you get here minus sigma r divided by 2 epsilon naught. Okay. And here if you put, oh, अच्छा हमसे लग रहा है कैलकुलेशन में थोड़ा मिस्टेक हो गया है. ठीक है. सी हियर एक्चुअली वी डिफरेंशिएटेड द फर्स्ट टर्म, सो वी गॉट दिस माइनस हाफ, एंड ये इसको भी तो डिफरेंशिएट करना होगा. सो व्हेन यू डिफरेंशिएट दिस, यू विल गेट हियर आर स्क्वायर प्लस जेड स्क्वायर होल पावर हाफ, और यहाँ पे होगा जेड स्क्वायर. ठीक है ना? 1 बाई जेड का डेरिवेटिव से माइनस 1 बाई जेड स्क्वायर आ जाएगा. सो दैट्स व्हाट वी आर गेटिंग एक्चुअली. ठीक है. तो अब हम देखिए जेड की जगह आर पुट कर रहे हैं, तो जेड की जगह आर पुट करोगे ना यहाँ पे, तो ये आ जाएगा, यहाँ से माइनस पावर है ना, तो ये 1 by root 2 r. And here if you put z is equal to r here, okay, you will get here minus root 2 by r. z की जगह यहाँ पे भी r होगा ना, ऊपर से r आ जाएगा और ये r square. Okay. And here if you put z equal to r, you will get 1 by r. Okay. That's what we get. Okay. So now you see, so this term I had actually forgotten to write. Okay. तो आप डिफरेंशिएशन करके देख लेंगे. दिस इज व्हाट यू आर गोइंग टू गेट. ओके. सो नाउ इफ यू टेक 1 by r कॉमन, so that will cancel with this. So sigma upon 2 epsilon naught, and when you take LCM, root 2 multiplied by 2, it becomes 2. So 1 minus 2 minus 1 हो जाएगा, तो ये minus 1 by root 2 आ जाएगा यहाँ पे, और यहाँ पे आ जाएगा minus 1. Okay. So when you multiply by this minus, okay, you are going to get here sigma upon 2 root 2, ठीक है, अपॉन और epsilon naught. This is 2 root 2 and minus minus plus. So here you get sigma upon 2 epsilon naught. Okay, so that's the answer. Okay, तो अब देखिए कि यहाँ पे जो इलेक्ट्रिक फील्ड निकल रहा है, ठीक है ना, when you put z is equal to r. Okay, so electric field at z is equal to r, we are getting is equal to this much, sigma upon 2 root 2 epsilon naught plus sigma upon epsilon 2 epsilon naught. Okay, so that's the electric field. Okay, now you see by this method we got electric field to be equal to this much. Okay, but here we were getting electric field sigma upon 2 root 2 epsilon naught, so definitely this is not correct answer, and mistake was because of this term. Okay, sorry, this term. So this integrand was actually vanishing at this denominator was vanishing at at theta equal to 0. So this integrand was not defined. Okay, at theta equal to 0. So that was leading to a mistake. Okay, so when we just change the mathematical approach, okay, we did not do any concept. See, physics we have not changed. Physics remains the same. We have only changed the mathematical approach, and it is giving now the correct answer. So that's the answer. Okay.